What if the future of AI isn't built in Silicon Valley? What if it's built on the power we already shut down? Not new land, not new networks, not new grids, old power. Because the next constraint isn't chips. We already know it's electricity. We're not building the future from scratch anymore. We're attaching it to the past. Welcome back to the New Financial World Powering Tomorrow. I'm your host, Zach here. Today, we go to where AI actually live. Not apps, not the models, not the hype. The physical layer underneath it all. Decommissioned nuclear power plants, retired power stations, and infrastructure we thought was finished. That infrastructure is about to become the backbone of the next system. But first, quick disclaimer. This show is for educational, informational, and entertainment purposes only. Nothing you hear should be considered financial, investment, legal, or tax advice. Always do your own research and consult a licensed professional before making any decisions. All viewpoints on this channel are my own and are not of any employer or organization. Now, let's get to it. In earlier episodes, we talked about AI reshaping electricity demand, the structural load shock, the race to secure capacity, and how capital is moving upstream. Today, we ask a more concrete question. Where can we actually plug in that demand fast enough to matter? The bottleneck isn't just how much power we need. It's where can we get it connected, permitted, and ready to flow without waiting a decade for new transmission lines or greenfield sites. Hyperscalers are already locking in power years ahead through long-term contracts and direct investments. Those agreements only deliver electrons if the wires, substations, and land approvals already exist, from pure generation to proven immediate access to the grid. What makes a site valuable for AI infrastructure today? Location. You can't drop 500 megawatt data center anywhere. You need it where high voltage lines already have coverage. Even with a perfect parcel, you could face queues of up to 5 to 10 years just to tap on the grid. Now, time is something we already know. AI roadmaps refresh every 6 to 18 months, while transmission projects move on multi-year cycles. The issue isn't the lack of generation technology. It's the places where generation already meets the grid. For instance, substations, switch yards, and transmission corridors. They are scarce and slow to create from scratch. That's why the most valuable infrastructure isn't the new wind farm or solar array. It's the sites where the grid connection already is built, paid for, and legally cleared. For years, the question was, where can we build new infrastructure? Now it's, where does power already exist? At scale, across the grid, sits assets built for massive electricity delivery. Nuclear power plants, coal stations, and gas facilities. Some are still running, many are retired and mothballed. But all share critical traits. High voltage connections, designed for gigawatt scale flows, industrial zones, they already permit heavy energy use. Physical security, they have fences, access controls, and monitoring, ready for sensitive workloads. Cooling infrastructure, river intakes, cooling towers, and heat rejection systems, mappable to serve farm thermal loads. These sites weren't conceived for the internet. They were engineered to move serious electricity, which accidentally makes them perfect for AI. So we're not just building data centers anymore. We're colonizing the footprints of the last energy era. Now, who's looking? Well, Talon Energy is selling power for its Susquehanna nuclear plant to Amazon Web Services, and that runs until 2042. Amazon is anchoring major data center investment around existing nuclear capacity in Pennsylvania. aligning infrastructure build-out with already proven grid access. Microsoft has secured a 20-year purchase power agreement with Constellation Energy to power its AI workloads. Various utilities and infrastructure funds like Brooksfield and BlackRock are evaluating brownfield and retired power site portfolios for AI data campus development. Now, compare two paths. Greenfield build, years of permitting, new transmission corridors, right-of-way battles, interconnection delays, uncertainty at every step. Repurpose site, the substation is already live. The transmission line is already connected. The land is already zoned for energy use. The capacity is already understood from decades of operation. So the core problem isn't just where is the power. It's how fast can we turn electrons into compute. Capital doesn't wait for permissions. It flows to where constraint is already solved. The winning question becomes, where is power already proven? Because proven power beats theoretical power every time. At the scale of tens of billions flowing into AI, electricity stops being a line item cost and becomes a strategic input. In our earlier episode, AI isn't the story, we talked about some key players like Microsoft, Meta, Google, and Amazon, and how their capital allocation exceeded tens of billions. Now, the federal side is moving fast. Under the Trump administration's AI Action Plan, the Department of Energy's Loan Programs Office delivered a $1.1 billion loan to Constellation Energy to restart 3 Mile Island Unit 1, bringing existing capacity back online, instead of waiting years for new builds.
The Trump administration is loaning Constellation Energy $1 billion to restart the nuclear plant once known as Pennsylvania's 3 Mile Island. State energy officials say the site, now called the Crane Clean Energy Center, will reopen in 2027. Constellation has a deal with Microsoft to power future data centers in the region. The original 3 Mile Island plant suffered a partial reactor meltdown in 1979 and is considered the worst nuclear accident in U.S. history.
It's just much easier to sell fear than to sell reassurance. Of course, it was an early reactor with some bad designs and a human error, but that shouldn't even be possible to happen. But you're right, even with mechanical system design problems, human errors, no meaningful radiation was released, no impacts on human health, but it scared everyone. And the China Syndrome movie was out then, and we had a society ready to be fearful of nuclear power. Fortunately, now we've got, 70 years of data from nuclear operating. It's the safest way to produce energy around the world, and we have far safer designs, operations, and experience today. So the reactor number 2 that had that failure, was long ago permanently shut down. This is reactor number 1 that ran all the way until 6 years ago, was only recently shut down, shouldn't have been shut down. And now we're working with Constellation Energy to get that back up. The United States needs more affordable, reliable, secure energy. People are tired of expensive electricity prices, and the Trump administration is all in to do something about it.
Blockchain-based tools are beginning to tie these deals together. Pilots by Power Ledger and LO3 Energy are testing peer-to-peer tokenized power trading for data campus microgrids. And several nuclear restart purchase power agreements are being structured on smart contract platforms to automate settlement and renewable credit tracking. Because at this level, it's not about accessing power. It's about controlling it across the industry. Capital is shifting into systems. That reduces dependency on the broader grid. Data center campuses tied to dedicated power sources, energy as a service contract that bundles compute with guaranteed electricity, infrastructure funds targeting brownfield and retired power sites for reuse. This isn't tech spending anymore. It's infrastructure positioning. And when you commit that kind of capital, reliability isn't optional. Even a few minutes of downtime translates into significant financial loss and operational risk. That's why nuclear is attractive, not as a political statement, but as a source that can deliver consistent, predictable output, matching AI's 24/7 baseline demand. In parallel, interest in small modular nuclear reactors is growing. Not because that's trendy, because their size and siting flexibility could bring proven nuclear-grade reliability close to demand, even if timelines and economics is still evolving. This isn't a nuclear comeback story. It's a load matching story. AI training and interface run continuously, requiring constant, uninterrupted power. Nuclear power plants were built to deliver exactly that. Steady, baseload output with high capacity factors. So the alignment isn't about ideology, it's about physics. AI is the truly first digital baseload. Nuclear is one of the few industrial systems that can meet it without swinging with the weather or the market. That's why interest is building, not just on new builds, but also on existing nuclear sites. They already solved the real problem: reliable power at scale, with the grid connection already in place. And if you think this stops with retired power plants, it doesn't. That's when you know something has shifted. When yesterday's defense infrastructure becomes tomorrow's economic infrastructure. There are serious proposals being explored to repurpose retired nuclear reactors from military ships, aircraft carriers, submarines, as dedicated power sources for data center campuses. Not building new reactors, reusing what already exists. Military-grade reactors were designed for reliable, compact power and long operational life in harsh environments. Now they're being studied as potential anchors for AI infrastructure. These concepts are still early. Feasible studies, policy conversations, and developer pitches. Because the fact that they're on the table tells you how valuable proven, hardened power has become. It sounds extreme, but it follows the same exact logic we've traced this entire episode. When time, permitting, and transmission become the bottleneck, you don't start from scratch. You start with what's already hardened and already proven to work. In other words, we're not just repurposing the grid, we're repurposing the Cold War. The shift that's happening, it's about how infrastructure gets built when demand moves faster than the system can respond. The next digital economy won't be built where land is cheapest. It will be built where power is already proven and where paperwork is already done. Data centers aren't tech infrastructure with power attached. They're energy infrastructure with computers attached. And once you see that, the map changes. You stop looking at tech as hubs. You start looking at substations, transmission corridors, and the ghost of old plants. Because we're not building the future from scratch anymore. We're attaching it to the past. And in this system, AI doesn't go where the interest is. It goes where the power is. If you found this episode helpful, smash that like button. Subscribe for more deep dives on the real infrastructure and share it with anyone who needs to see where the convergence lives. Because this show doesn't chase headlines, we break systems down, not as trends, but as forces shaping how the real world actually works. Until next time, learn, adapt, and prosper. And as always, stay energized.